Okay, so I'd like to now work this centripetal acceleration problem. And in this problem, we have a car traveling at a certain speed, and it's traveling in a circular path. We want to calculate what its centripetal acceleration is. So here's our circular path, then, that the car is traveling on. And we're told the car has a speed of 25 meters per second. Okay. And the radius of this circular path is 500 meters. And so remember, centripetal acceleration is v squared over r. It's velocity squared divided by the radius of that circular path. So the velocity is 25 meters per second. The radius is 500 meters. So we do that calculation, 25 squared divided by 500, and we get the number 1.25 meters per second squared. Okay? So that's the centripetal acceleration. And of course, it's centripetal acceleration, so it's not actually changing the speed of the car. The car is keeping this 25 meter per second speed the entire time. But what this acceleration is doing is it's changing the direction of the car. Okay? Remember, we know this car is accelerating because the direction is changing. Because remember, acceleration is a change in velocity. So whenever velocity is changing, there's an acceleration. So you can have either speed changing for an acceleration, or you can have direction changing and still have acceleration. And that's what's going on right here. So this is the magnitude of that acceleration. And remember, centripetal acceleration, the direction of that acceleration is pointed towards the center of the circular path. Okay? Okay. Now, part B of the question asks us to compare that acceleration to g. And so whenever they say compare, taking a ratio is probably what you want to do. So this acceleration divided by g, so 1.25 divided by g, which is 9.8, that gives you the number 0.128. Okay? Now if we multiply both sides of this by g, then, okay, well, the g's cancel over here, and our centripetal acceleration is 0.128 g's. Okay? So that's what people are talking about when they're talking about g's. How many g's is it? Well, this acceleration that this car is undergoing is 0.128 g's. So that's about, roughly, it's 12.8% of g. So basically what it would feel like in this car, it would feel like a force that's about 13% of the normal force of gravity. So that's something you easily feel in this car. You would easily feel this force then. And so it's pretty easy to get a pretty significant acceleration in any type of circular motion. Okay? So that's why this is a really effective way to simulate very strong forces.